Hi, I'm Barka Herman from StarTree. In this module, we'll figure out how ThirdEye is capable of achieving real-time anomaly detection by taking a look at the worker management. ThirdEye scales by increasing the number of workers, distributing the workload across all the workers it manages. In other words, in order to achieve the real-time nature of anomaly detection, it needs to scale workers and the workload across the number of workers and increase the workers as needed. A typical life cycle of a worker is it starts, checks the queue to see if there's any tasks that need to be completed. It locks that task so that no other worker can run that task, so each task is run only once. It completes the task, posts the results in a database, and then goes back to sleep. Now, if there are no tasks in the queue, it sleeps and then checks the task again. The worker manager, in turn, is responsible for making sure that each worker is working properly. Each worker has a unique worker ID so that the worker manager can track it. The worker manager makes sure that there are enough workers running in parallel so that the queue can be managed. If the queue is very small, there's a low number of workers. If the queue gets large, the worker manager is responsible for creating new workers to handle the load. Each worker, in turn, has an internal queue of locked tasks that it is using to pull tasks for its execution. Workers themselves work in a multi-threaded fashion, so while it's locked one task and it's waiting on a result, it can also pull other tasks for parallel execution. To make ThirdEye scalable, consistent, and efficient system, the worker manager needs the ability to have the scaling, load distribution, disaster recovery, as well as optimization. It does this by tracking how big the workload is, by maintaining how many workers it needs, by keeping track of which worker failed and what tasks were in that worker's queue so it can reassign it to other workers, and also by minimizing the points of failures within the system so that if something does fail, it can recover fast and efficiently, as well as tuning the workers based on known load patterns. In the next module, we'll learn about creating alerts.